Welcome to NASA STEM EPDC Quick Bits Science and Engineering Practices. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world, and finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
Welcome. My name is Sara Torres. I am the Education Specialist at NASA's Ames Research Center. The big idea of this Quick Bits is planning practices and conducting research. For example, planning and posing research problems to answer questions or test solutions, which leads to include research that controls variables and provides evidence to support explanations or design solutions. The title of this activity is Exploring the Moon in a Rover. In this activity, the student will participate in the following exercises. Make predictions about what will happen if changes to a variable are made, and create two different models of the same object to determine which one best meets the success criteria. In this activity, the student will work on making a design of the exploration vehicle better by changing a variable. In this case, the shape of the wheels. NASA's new focus is to return to the moon in 2024, and from there continue to Mars, with new technologies and resources to continue deep space exploration. This is called Moon to Mars. The most recent exploration vehicle that NASA will deploy to the moon is called Viper. NASA has launched 4 exploration vehicles to Mars. They are called Sojourner, Spirit, and Opportunity, which were launched at the same time, and Curiosity. Perseverance launch took place on July 30th, 2020. NASA launches those exploration vehicles to explore places that the astronauts are not able to explore, therefore protecting their lives. Next, we will watch a video of exploration vehicles that have reached Mars. On the following website, you can find the activity Exploring the Moon in a Rover, which is an exploration vehicle. We challenge you to design and build an exploration vehicle that can move on the ground powered by rubber bands. Remember that an exploration vehicle's design can be made better by changing a variable, in this case, the shape of the wheels. To design an exploration vehicle, it is best to utilize the engineering design process. The first step is to ask. The second, to imagine. This is followed by making a plan, then to create, and next to perform a test, and to improve. What will we be testing? In this activity, we will test if the vehicle moves forward with square wheels. If it does not work with square wheels, then we will change the design of the wheels. Lastly, we will share. This process is performed in a circle because the steps are repeated. Materials needed for this activity include corrugated cardboard of about 15 square centimeters for the body of the vehicle, 2 13 square centimeter corrugated cardboard wheels, a round pencil, 2 elastic bands or rubber bands, a ruler, adhesive tape, round-shaped mints with a hole in the center, and a plastic straw and scissors. Remember to write down your plans in your journals or notebooks. First, you have to build the body of the vehicle. Fold the cardboard into 3 parts. Each part will be approximately 2 inches wide. Fold along the corrugated area. To make the front wheels, draw diagonal lines from corner to corner on two 13 square centimeter cardboard pieces. Make a small hole in the center. On the body, make a hole near the side of each axle. Make sure the holes are directly in front of each other and are large enough so that the pencil can rotate freely. Now attach the front wheels. Slide the pencil through the holes in the body axles. Push the wheels at each end. Secure them with tape. Next, make the rear wheels. Tape the straw to the rear of the vehicle. Slide a candy on each end. Bend and secure the axle with adhesive tape to prevent the candy from coming out. Finally, put on the rubber band. Loop one end around the pencil. Make a small cut in the rear of the vehicle's body. Slide the free section of the elastic band through the cut slot. It is time for planning and conducting research. The variable that I will change is the design of the wheels. In the first design, the wheels are square. Remember that I will only change one variable at a time. In the second design, I will change the shape of the wheels, and this time they will be round. In the third design, the wheels will be all-terrain. Now, in regards to the testing, what do you think? Do you think that the body of the vehicle will roll with square wheels? Make sure to write down your observations to make improvements to your design later. Are the square wheels rolling? And what about the round ones? We can change the design of the wheels to all-terrain. What differences do you notice? It is time for you to make predictions about what would happen if changes were made to a variable. What would happen if you change the material of the wheels or the body? What will happen if you change the size or measurement of the wheels? Good luck making your designs! These are questions that will help you improve your rover.
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links.